Hi, my name is Kurt, and today I'm going to show you how to use the Kappabridge for doing anisotropy of magnetic susceptibility. And here we have the Kappabridge, and it comes in three parts. There's a computer that controls it, there is the main unit, and there is the sensor over here where we put the samples in. And before we do that, I'm going to show you how to load samples in. We're going to measure them in 15 different positions. We measure them in this device, how we load it in here. So here is a pretend sample, and It's got a lab arrow on the top here, and this arrow is our reference point for measuring this, and we're going to load it into this little cylinder. So we'll do that, and up here we have our chart for the positions, for all 50 positions. So this first column corresponds to the single line. And so position 1 is going to be with this first dot right there. And then position 2, then we rotate the arrow like so, down like that. So that goes for the first 5 positions. Do 15 of those for each sample, and it goes over and over again. So what am I trying to do with these cubes? The thing I'm trying to do is look at landslides, and we take cores in those landslides and next to them, and we try to look for evidence of grains shearing and deforming. If we think about an original sedimentary fabric, we'll just use this sheet of paper as an example for what a grain does. When it falls into the water column, flopping around, as it comes to the bottom, it's not going to want to stand up on its end. It's going to want to fall over. And there's a short axis, an intermediate axis, and a long one. So when it falls, it's going to be oriented randomly. There's going to be grains landing in all different directions. So we'll have what's called an oblique fabric. And then in a landslide, you'll then shear this, and you'll actually have a shear force go through and line up the long grains sort of all in the same direction.
Inside Bruno's sensing apparatus, the electromagnetic coil wrapped around the sensing area produces an oscillating magnetic field. The constantly changing field induces a current in the sensor coil nearby. When a sample is present, it becomes magnetic and responds to the shifting magnetic field produced by the first coil and oscillates with it, so that together they induce more current in the sensor coil. An anisotropic sample becomes magnetic to different degrees depending on how it is oriented to the coils. By measuring the sample in several orientations, scientists can calculate which orientations result in the most induced field. Although measuring the sample in 15 positions is not strictly necessary, it allows researchers to calculate error.
And then we need to calibrate the machine. Being that these are sediments, they're pretty weak, so we need to go down to a low range here. We're going to have to calibrate this in 2 different places. One is right here. This is IM, and the other one is on top of the machine right here. And the one on top of the machine controls the left-hand little graph here. So we're going to tune that to be 0. And the right-hand one controls the right-hand one, so we're tune that to be 0 also.
Okay.
And then we let the machine calibrate itself until it says ready. Okay, so it should be almost done. And the important rule when working with this on low settings is not to have a belt or a wallet or a cell phone on. I'm wearing my wedding ring on my right hand so that it doesn't get in the way of the machine. Even pennies waved around can disrupt the readings. So first we're going to go ahead and calibrate our sample holder. It says ready, hit measure, goes to measure, and we drop in the sample holder. Alright, it seems to like that. So we recorded our sample holder range, and so now we're going to measure our first sample. And we're going to load up the sample. In this case with cubes, my primary arrow here is in dashes, and I'm going to put that in the sample holder. So it's loaded in just like that. This is position 1. And we're going to click measure sample. So it says ready in the center here. I'm going to go ahead and click measure. And I drop in the sample. Beat, and out it comes. And I'm going to now measure position 2. And it says ready, so measure. that's all we do for one measurement, so repeat that a couple hundred times and you have yourself a PhD thesis.